Let's look at solutions a little bit more now. We're going to go into Raoult's law, and Raoult's law, R-A-O-U-L-T, Raoult's law deals with the fact that you can change the freezing point and boiling point of substances. Okay, so in this case, if you have a solute dissolved in a solution, in a solvent. So in this case, we look at the freezing point depression calculations. So again, if you add a solute to a solvent, you will depress the freezing point. Okay, so that's the calculations we are doing here. So question number 1 for us is, what is the freezing point of an aqueous solution of sucrose that has 25.0 grams of sucrose? Information is given to us per 100 grams of water. Okay, and the Kf of water is given, which is the freezing point constant. You have to be given some information in these calculations for you to be able to do these things. Okay, so if it's not given to you, go ahead and look it up in the book also. In an exam, you will probably get all of these constants. So how do we get started? Well, for this one, you have a formula, and delta T is equal to minus Kf times molality. Okay, so that is how you would figure out how much of the change in temperature is occurring. All right, so which means that what we need here is the Kf, which is given to us over here, and then we also need the molality, and molality of course is moles of solute over kilograms of solvent. Okay, so that's what we have, so that's what we will calculate first. So molality, I hope you can follow this one quite easily. It should not be that hard. Molality of solute over kilogram of solvent. Okay, so the moles of solute is 25.0 grams of sucrose, and then you find the moles by dividing it by 342 grams, and then mole here, which is equal to 0.0730 moles. Now the kilogram of solvent, okay, is 100 grams, and then just convert it to kilograms. How easy is that? 1000 grams has 1 kilogram, so that's equal to 0.1 kilogram. You divide the two numbers now that you have both of them, and you get 0.730, and this is molality now. So all you have to do is plug the information in. So delta T is equal to minus Kf, and minus Kf would be then minus 1.86 degrees Celsius per molal times 0.730 molal solution. So your molal is gone, and so then we are left with minus 1.36 degrees Celsius. That is the change, okay, that you will find in the water. Now the freezing point of water is 0 degrees Celsius. So the change then is, of course, the new the new freezing point is going to be minus 1.36. Always remember that your freezing point is going to depress, so your answer will always be lower than the original. Okay, so for water it's fairly easy because water is 0 degrees Celsius. Okay, so that's your final answer there, 1.36 Celsius. Okay, let's do another problem now. What is the freezing point of a solution with 10 grams of naphthalene? Again, information is given to us, is dissolved in 50 grams of benzene. So again, some of the constants are given to us, the Kf of benzene and the freezing point of benzene is given to us, because it's not like water, okay, it's not in our minds. So again, we will have the same formula, which is the delta T is equal to minus Kf and the molality. Okay, so again, we're going to calculate the molality. You're probably getting bored by now. So molality is moles of solute over kilograms of solvent. And if you're getting bored, you can go ahead and fast forward me right now. So 10 grams of naphthalene, okay, which is over there, divided by 128.2 grams per mole. Hopefully you're all comfortable with this now. And this is equal to 0.078 moles. The kilogram of solvent is going to be 50.0 grams divided by 1000, and that is 0.05 kilograms. Divide both of these numbers and you will get 1.56 molar. And once you have that, you bring it to your formula, which is delta T, and minus Kf is minus 5.12 degrees Celsius molar, and then times the molality, which is 1.56 molality. Molality cancels out, and our new temperature then is equal to minus 7.988 degrees Celsius, and that's the new temperature. Okay, the original was 5.53. So if original is 5.53 degrees Celsius, so then all you have to do is subtract. So the change is minus 7.988, which is equal to T final minus the T original, which is the 5.53. Okay, so T final is minus 2.46 degrees Celsius. That's a lot of depression. You know, it's about 8 degrees that you have lowered for the freezing point. Okay, so yes, these kind of solutes do have an effect on different kinds of solvents. So again, remember, your new freezing points, if you have a solution, is always going to be lower than what the original is.